So we're going to keep it aerobic by using air blowing into your tank of water to move the water. So we're going to extract the organisms off the surfaces. We have to make sure oxygen's adequate. And again, it's looking at your organisms. The organisms respond most rapidly to what's going on in that water. Your organisms will tell you when you're starting to go anaerobic, and you need to fix that kind of problem. Water extract, so we've already gone through a lot of this. The energy to extract the organisms off of the surfaces. What's the temperature of the water that you should be using? Ambient temperature. Wherever you're going to be applying that tea. I know that people will always tell you that organisms grow faster the hotter it is, the warmer it is, the faster the organisms are going to grow. Yeah, except which organisms are you going to be growing? The ones that grow at that temperature. What if your outside surface of your leaves is 40 degrees and you're brewing at 95? All those organisms at 95 degrees, if you're out on the beach in Waikiki in your little bikini and your Speedos, and we suddenly transport you to the middle of downtown Minneapolis, Minnesota in the middle of the wintertime, what are you going to do? You aren't going to do your job, are you? You're going to freeze to death. So match the temperature you're brewing at to the temperature of the place you're going to put that compost tea. Yes, if you're in Las Vegas in the middle of the summer, brew at 110 degrees. Okay. It's a little fun trying to keep that aerobic. So have some fun every once in a while. So brew at the temperature. And again, we deal with salts in your soil, in your water, on the pH problem. Don't worry about it. Your microorganisms are in control of that. We're going to get rid of the salt in your water, the toxics in your water, by putting in the humic acid complex in that. So the definition of compost tea, as opposed to compost extract, as I've already gone over, with the extract, you're just using the water to rip the organisms off the surfaces of the compost, and you're ready to roll. We don't have to be adding food. So if we go back one, we're going to add foods to a compost tea to grow the organisms. So we have to understand what foods to grow which kinds of organisms. So which is better to use? What do you need? It's always going to come back to what do you need to be doing? Are you going to just need to inoculate these organisms into your soil? You've got plenty of foods in your soil. How do we know we have plenty of foods in our soils? What's the percent organic matter that our soil should be at that will maintain this life even when your plant's not growing? We have to have foods for these organisms to grow on. So what's the minimum percentage organic matter that we have to have in soil for our organisms to make it through the wintertime? At least 3% organic matter. If you're lower than that, spend your life increasing that organic matter in your soil. How fast can you get that organic matter? How fast can we go from 0.5% organic matter to 3% organic matter? One application of compost is typically all we need, as long as you've got some residues, as long as you've got some undecomposed plant material, and those organisms can start to chew on it. So compost in place. Put down layers of your residues, get the compost or the compost tea on top of that, and get that decomposing in place. Because then you don't have to, if you got to collect all your residues off your soil and compost it all over here, and then go spread it all back, ouch, that's painful. So make small amounts of compost. Get that really good inoculum. And then go spread that over the surfaces of all your residues on your farm. Best time of year to do that? In the fall, when you have fall rains. And then all winter long, your microorganisms have the chance to decompose those residues. And by next spring, you got soil, beautiful soil. As long as you have the life in that compost. Well, do you have to spread solid compost, or can we spread a compost extract? So if we're going down onto our soil, compost extract. You don't need to be growing the organisms As long as you got good compost, just do an extract. You don't have to brew. You don't have to add foods. But what if you don't have a lot of compost? You've got, a 3-foot tall pile by 3-foot wide pile, and that's all the good compost you've got. And you've got 10,000 acres that you have to cover. Okay, you're still going to make tea because you're going to have to grow those organisms in that brewing process to get enough to take that tiny amount of compost and turn it into an inoculum for all of your fields. So there's that size thing we've got to think about as well. Compost leachate. How many of you have heard about compost leachate? Quite a few of you. So let's put it straight here. Compost leachate is what happens when you just passively run water through your compost. So when I was talking about making the humic acid, that's a leachate. We passively move water. And you collect that liquid. It does not contain the organisms. It should not contain any of the organisms, because if we've got happy, healthy organisms, they are glued. They are bound to the organic matter in our compost. So a leachate is just going to have the enzymes, the hormones, the soluble organic material, the soluble inorganic nutrients that might be present in your compost. So short-term benefit. You may see an instant response of your plant because we've got some good enzymes that went in there. There were some soluble nutrients. There were some good humic acids. But it's a very short-term response. You're going to see a benefit to your plant of maybe a week, maybe 10 days, and that's it. Because the biology in your pot has done everything it can possibly do with that. So compost leachate, there's your humic acid. Compost extract, we're ripping the organisms off the surfaces of the compost, but we're not feeding them. They're not going to be growing. If we're making tea, then we are indeed growing the organisms, and that's why we have to brew. We have to give them time. Typically at 72 degrees, we're going to brew for 24 hours. If it's colder than that, we're going to brew probably for 36 to 48 hours. We want the organisms to use up all the foods that we put into the compost tea. And that's going to take time. The colder it is, the slower they're going to grow. Now, just to differentiate a couple of other things, plant teas, there is no compost involved. When we're doing biodynamic work and you're putting, comfrey leaves into a tank and you're filling the tank up and you let that ferment away, that's a plant tea. There's no compost involved. Oh, but I took a pinch of my horn manure compost and put that in there. Yeah, that's an inoculum of organisms. That's not compost tea. Compost tea has to be made with a lot of compost. So differentiate that. Can plant teas be useful? Absolutely. But what's the biology in your plant tea? Exactly what did you do? What did you grow? A whole different story. Easiest way to know what's in a plant tea is to look at it with your microscope. And you've got to be managing a plant tea correctly because it always goes through an anaerobic phase when we start that plant tea. For as long as that plant tea stinks, smells bad, you probably don't want to be putting that right on your plants. Because there's some diseases, there's some pests, there's some problem organisms in there, and you could be applying them to your plant surfaces. Manure tea. Time and time again, people have made this mistake. They will go and take manure straight out of an animal or been sitting around on the barn floor for a while, and they throw manure into the bucket, swirl it around, get it nice and aerated, and then they leave it overnight sitting in the garage or sitting in the kitchen. What happened when you weren't stirring it? How anaerobic did that go? And when I read in the scientific literature and people are describing in papers, they say compost tea doesn't work. And I read the methods, they took manure. Well, what's in manure? Anaerobic organisms, because think about the cow's digestive system. Is that aerobic or anaerobic in there? Anaerobic. So what's coming through in the manure? A whole bunch of pathogens. And so if we take that manure, put it into water, we spin it around for a while, but then we leave it setting overnight. How fast did it go anaerobic once you stop stirring? Probably about 20 minutes. Anaerobic, what are we growing in there? So these papers, they take that manure water, let's call it what it actually is, manure tea, if you will, and they spray their cherry plants with it. What's going to happen to your cherry plant? It dies. I'm not surprised at all, because we put out some wonderful pathogens that were only too happy to take out your cherry tree. But in no way is that a test that shows that compost tea doesn't work. They didn't do anything to make compost tea. They had no compost because what they used was manure. So when you're reading some of those papers, if there's no mention about biology, scientific paper has to be looking at the biology. What's in the compost, what's in the tea when they get finished, demonstrate that it's actually the beneficial organisms that you're putting out. Yeah, so a worm tea, exactly what that is that. You're going to have to go back to the person who made it and find out how they made it. Because if you got a worm bin that's constantly dribbling water out the bottom, what does that tell you about that? It's anaerobic, yeah. This is anaerobic. So what's in that worm tea? And we really shouldn't call it tea. Yeah, we should, anaerobic, stinky, smelly liquid stuff, ugh. So now what if their worm bin, they are purposely, like once a month, putting on a lot of water, letting it pass through and collecting that liquid. Okay, now I'll give you that. That's some really great humic acid that should have all those enzymes, all those hormones. But it's passive movement of the water through the worm compost. So it should not have any organisms in it. So don't expect the inoculum of the organisms in there that you would get in an actual compost tea or a compost extract. Passive movement of water through a compost does not pull the organisms out. When we're looking at soil, where the organisms are actually growing in the soil is in the soil solution. So these are all basically aquatic organisms. They're just adapted to gluing themselves to the surfaces, binding themselves, but what they're really living in is the soil solution. So we're just increasing the amount of water. There's more space between surfaces when we're extracting these things into the compost tea, doing a compost extract. They're not really in a milieu that's that different from the soil. Now, if we try to, rip the organisms off the surfaces and somehow extract, pull away all of the solid material, I think things would grow very differently where we don't have any surfaces for these organisms to grow on. But when we're doing these compost teas, there's always small little bits of the organic matter coming with. We've got the sands, the silts, and clays often. Certainly the clays coming through with the bacteria. Clay is the same size as a bacterium. Rod shape, but, same size. So we are only subjecting them to these kind of, things are getting a little strange, conditions for these organisms for a short period of time, and then we're putting them back out into the real world, which is why we don't want to have, some people say, well, Elaine, why can't I start a tea brew and then just keep adding to it? And, for the next 150 years, we'll have this compost tea. Because only one or two species win in competition, and that is not adequate. We have to have this massive diversity of organisms. And that's why we want this compost with all these different kinds of food resources in there, all these different kinds of conditions in that pile, so we can maintain this massive diversity of organisms. When we look at a typical gram of healthy soil, there are 75,000 species of bacteria per teaspoon. There are 25,000 species of fungi per teaspoon. 1,000 species of protozoa, and maybe 10 to 100 species of nematodes per teaspoon. And that's the kind of diversity that we have to have. So somebody's always awake and functioning around your root systems every second of every day that your plant is growing. Your plant will never be stressed. It will never have problems with oxygen getting to the root system. But if we have that kind of diversity, so somebody's always building soil, somebody's always protecting your plant surfaces, somebody's always cycling nutrients. So we have to get this diversity back into the soil. So diversity is a very important part of all of this. So factors involved in making good compost tea. The things we need to think about, so we really get through all the basics here. Well, first of all, I'm hoping that you've all got this down. The compost has to have the organisms. They've got to be the aerobic organisms. You need to have the nutrients. As long as you're making your compost out of organic matter, no need to worry about the nutrients. Every single plant cell has to have the full complement of nutrients in it. If you got organic matter in your soil, stop worrying about putting on any kind of fertilizer because you don't need it. Get above 3% organic matter. Yep, the organisms are going to be able to take the nutrients out of that. So in our compost, we've got the nutrients. We need to make certain the organisms are there. Then we've got to look at the machine. How are you aerating? How are we extracting those organisms from the surface? We got to get that water moving. And it has to be rapid enough that we are actually extracting off all of those surfaces. So what kind of pump? Well, now this is an air pump that you should be using. You do not want to be taking the tea out of your tea brewer through a pump and pumping it back in through some kind of nozzle. Every time you pass your tea through that pump, it's killing some organisms. I don't really care what kind of pump. I've never seen any pump that doesn't have damage done to the organisms as they're passing through. Some pumps aren't as bad as others, but especially in a tea brewing operation, if all of the water in your tank is going through that pump every 5 minutes, and we have a 20% attrition rate, how can you have good biology left in that tea brew? So we want to be using an air pump. So however you want to get the air down to the bottom of the tank and release those air bubbles, why not a nice, the valve at the bottom of a cone tank? And just hook your air pump up there. So valve, you close that valve, you fill up your tank with water. You turn your air pump on. Please make sure that your air pump is above the level of the water in the tea brewer, just in case the electricity goes off. Because you don't want to have this little explosion happening when the water hits your pump. Yeah. So make sure that pump's above, or, the pipe or something is above at some point. So now you're, turn the air pump on, open the valve, bubble, bubble, bubble. There it goes. Right from the very bottom. So you don't have any collection of sludge that's going to occur on the bottom of that tank. If you've got a tank that develops a layer of sludge on the bottom, as your water is moving through the course of extracting, any of your water that passes through the sludge on the bottom of the tank is going to happily filter out all your bacteria, your fungi, your protozoa, your nematodes. And so all of your biology is going to be left on the bottom of the tank, not in the water. So be aware of these kinds of problems. And when you're going to go buy a brewer, make sure you can see every part of that brewer. Because if something's enclosed, something is where you cannot see it and you cannot clean it, guess where the sludge is building up? So don't even consider tea brewers where you can't see part of the inside of that system. Closed pipes, bad news. A little chamber where you can't see inside. Oh, we've got a little crystal down there in this chamber, and that crystal is going to help improve the growth of the organisms. Really? Could you show me the data on that? Because little enclosed chamber, guess where the sludge? You open up the chamber after 5 or 6 tea brews, get your saw out, saw it open, and the slime on the surface of the crystal is just ungodly. God. Question back there? I'll go through some brewers that, good or bad, I'll go through them. So cleaning your machine, again, if you can't see some surface, how do you know when it needs to be cleaned? So biofilms will form anywhere the water slows down, anywhere the water is not moving very rapidly. So that means edges. That means 90-degree turns. That means pipes. Where the water is going to slow down as it passes through, that's where the biofilm is going to start to develop. So bacteria start gluing themselves to the surface of the plastic or the surface of the metal. And one layer of microorganisms sitting there, not a problem, because plenty of oxygen in the water going by. But then these bacteria are going to reproduce. And now we got 2 layers. And now we got 4 layers. And now we have 16 layers. And now we have 84 layers. So if any of these organisms that first attached are capable of growing in reduced oxygen conditions, and some of them will be pathogens if you're not just absolutely certain about your cleanliness. So now we could have pathogens starting to grow. Anaerobic conditions, we're starting to put out some toxic chemicals. We're starting to produce alcohol. We're starting to produce valeric acid, putrescine, all those nasty toxic chemicals, formaldehyde, and the quality of your tea is going to plummet. So we have to be able to see where those biofilms are starting to form. So make sure when you're buying that brewer that you can see every part of the inside of that brewer. The simpler, the easier, the better, in my opinion. I do not like cleaning, as you might suspect. I am not a fan of cleaning anything. My idea of cleaning stuff is take the hose, put my thumb in the end, and blast it out. And just clean it all out, high pressure water. I do not have to climb inside the tank. I've been stuck inside tanks too many times. Big 500-gallon brewer, and we got to go down and scrub the port that takes the water out. So you climb down inside, and of course you don't think about the fact as you're climbing down inside and you let go of the lid and you drop 4 feet. How are you getting back up there? And they all went off for lunch while I was cleaning the tank. So I'm inside the tank going, anyone out there? Hey, guys. Finally took a nap. They came back. They couldn't find me. They started putting water in the tank. I woke up. So, some of the stories you can have. Cleaning, make it easy. Don't have stuff inside the tank if you possibly can. Temperature, we've already talked about that. Hotter is not better. We have to match the brew temperature to where you're going to be putting it. Foods, what's missing in your soil? You got to check your soil, and you put in the food for the organisms that aren't where you want them to be. What's the balance that your plants require? Weeds require strictly bacteria. If that's all that's in your soil, that's what you're growing. You got to start having that fungal component. If you want to grow brassicas, you have to have at least 200 parts per million fungi, 300 parts per million bacteria. Definitely on the bacterial side, but you need some component of fungi in order to not allow the weed seeds to germinate and start to grow. There are many, many places where we've demonstrated this over and over and over again. As soon as you start to shift that fungal to bacterial biomass ratio, the weeds don't grow. You don't have thistle, you don't have nutgrass, you don't have Johnson grass, you don't have whatever weedy species you want to talk about. Pardon? Get the fungal to bacterial biomass ratio. So we're starting to get a lot more fungi than bacteria. Now it's going to depend on exactly which kind of plant you want to grow. But even brassicas have to have some fungal biomass in the soil. And that's what selects against the weeds and for your brassicas. Now you want to grow most of our vegetables. We need to have about 300 parts per million fungi and about 450 parts per million bacteria. And we're going to grow our tomatoes, our potatoes, our carrots, our celeries, and no weeds. And we will increase water holding capacity so you don't have to irrigate. So the necessity to get this biology back into the soil. If you're trying to grow really healthy pastures or row crops, you have to have an equal biomass of fungi and bacteria. So you got to check your soil. What's in your soil? What's missing? And now we're going to use our compost extracts, compost teas, to put back in the biology that you're missing. So do we need to feed our organisms? The compost doesn't really have quite enough fungi, so I need to put in fungal foods. Because my fungi are low, I'm going to grow some, and I'm going to put fungal foods in there. So what are fungal foods? Just hold on, we'll get there. So water, we've already talked about this. Time of day that you're going to apply your tea. If the nozzle on your sprayer is large enough, it makes absolutely no difference what time of day you spray. If the nozzle opening size is less than 1 millimeter, then you're going to have to be careful about ultraviolet. On a bright, sunshiny day, you have to spray tea before 10 o'clock in the morning, after 3 o'clock in the afternoon, because ultraviolet will kill the organisms if your drop size is less than 1 millimeter. How do you know what size drop your sprayer is putting out? You take a piece of tablet, white tablet paper, yellow tablet paper, put it on the ground. Or, use a clothespin to clip it up onto one of your leaves. And then you go through with your sprayer. The instant you pass through with your sprayer, take a look at that piece of paper and you can measure the drop size. That's it. This is not rocket science. So, as long as that drop size is bigger than this, you're okay. Spray whenever you want to. Foliage or soil. So, nozzle size, there we go. B, please look at your sprayer and make sure you've removed all the filters. Because if you got a filter in line, you're going to develop a sludge as your compost tea goes over through that. It's going to end up forming a sludge, and now where are all your organisms going to end up? On the filter. Not going through and protecting your plants. So exit all filters, which is why you want your nozzle sizes pretty large, greater than 1 millimeter. Check your pumps and make sure that the pump is not killing most of the organisms. So get a diaphragm pump, are usually the easiest on your organisms. And yes, we are passing our organisms through that pump once, but just once, not once every 5 minutes. If you have a recirculation pump on your sprayer, please check that. Just think about the fact, though, that as you're driving down the road, as you're driving through your field, and that sprayer with your tank is bouncing along behind you, isn't the bouncing enough aeration to keep that aerated? Yeah. You don't need that recirculation pump. It's if you stop and you leave that sprayer sitting for, half a day. Yeah, it's not tea anymore. Dump it out on the ground and start over and clean the tank because you got some fun biofilm growing. So if you have to leave the sprayer sitting for any length of time, get the recirculation pump on. So don't do that, basically, is the take-home message. Question?
When you're brewing when you put your compost into your brewing vessel, is there a certain diameter, like the bag that you put your compost in? Do you want like a fine mesh bag, a large mesh bag?
Yep. So he's asking about the bags that we're putting our compost into, and so I should have talked about that back up here with the design of the tea brewer. You want to be putting your compost into a bag that the opening size on the bag is greater than 400 micrometers. So there's 6 different scales of mesh sizes, so I'm not going to go there. You want to just look and make sure that the opening size, get your microscope, put a little bit of that fabric underneath the microscope and measure the opening size. All of your organisms can pass through opening sizes that are larger than 400 micrometers. Most of the particulate material in your compost is going to be kept in the bag, so we're not going to get big chunks of stuff coming through. And there's quite a few of them. I'll show you some of the bags in just a minute. Question there? Typically what we want to do is have enough airflow so that as the air bubbles are leaving the surface, you have a rolling boil. You don't want, big fountains of water popping out of that's too high. We want enough so it's like a rolling boil on the surface. Yep, it should be fairly centralized, and typically what we're trying to do is bubbles coming up off the bottom, passing through your compost bag. So your compost is constantly mixing and moving and bouncing around and extracting the air bubbles, go on out of the surface of your water is going to move around. And so you set up a vortex, quite often a torus effect. So we do see improvements in the rate of growth of the organisms when we have that vortex happening. So almost every brewer you're going to encounter is a vortex brewer. I know there are people out there that say, ours is the only vortex brewer. Really? Right. Not true. So, yeah, the bag right in there.
About siphoning straight into a drip irrigation system.
About siphoning straight into a drip irrigation system? Absolutely. Just make sure the filters are out of the irrigation system. Typically with a compost tea, we're going to be adding it into a lot of water. Because when we make a good compost tea, really good compost tea, you're putting out 1 gallon an acre. If it's an okay compost tea, 5 gallons per acre. Not so wonderful compost tea, 20 gallons per acre. So into an irrigation system. Typically we're putting out, 2,000 gallons through the irrigation system. So we want to be metering that 1 gallon or 10 gallons or 20 gallons into that 2,000 gallons of water. The water is just a carrier. What we want to be thinking about is we're delivering these organisms at a high concentration. The inoculum we got billions of organisms in here. And so we need to spread that equally out over this 1 acre. It's just an inoculum. They're getting into the soil, they're getting into your organic matter, and now they start to grow. The joyful thing about life is it reproduces. We don't have to put on the right number of bacteria to occupy all 2 million pounds of soil in your top 4 inches. So get the inoculum out there, get them growing. And your plant's going to help because of the exudates coming out of the root system of your plant. So nozzle sizes, pumps, application factors, what's missing in the soil. Make certain that we're getting that out there. And then 2 weeks after you apply this compost or compost extract or compost tea, let's check the soil again. You got the microscope? Use it. How much improvement in the biology of the soil happened? Have we reached the goal? No? Then we put out some more. Let's say I go out and I put on my application of compost tea. I know I had just bacteria in my soil. I had no fungi, no protozoa, no good guy nematodes. The only type of nematode I had was root-feeding nematode. I apply my compost tea. 2 weeks later, I come out and look, and there's not a root-feeding nematode to be found. I've got bacterial-feeding nematodes. I've got my fungal-feeding nematodes. My fungi are going crazy. My protozoa are happily decreasing. My bacterial population, yay, nutrient cycling. Life's wonderful. I've done it. I'm going to see the benefits I want to see. And let's say you come out 2 weeks later. You look in your soil and you go, I'm finding root-feeding nematodes. I have no fungi. I have no protozoa, and I got bacteria out the gazoo. There's something toxic in your soil. There's something left over from, pesticides to high salt levels. You got a serious problem because you didn't get any benefit. Okay, that's where we're going to go find that inoculum of those pseudomonads and those bacillus species. We're going to go out and find some specific things to chew up the toxic material that's in your soil. I don't care what kind of toxic material it is, these guys are going to do the job. So I don't have to identify what kind of pesticide. I don't have to identify that it's clopyralid that's gotten out into your soil. I'm going to go get these good guys. You make another tea where we add, at the beginning of the brew cycle, these particular organisms. And so we're going to solve the problem 2 weeks from now. We're going to look again, and we're now in the right direction.